In this video, we're going to discuss certain operations that you can perform on matrices. So the idea is that we're going to have a matrix, we're going to do something to it that's going to change the matrix in some way. The first thing, the most simple operation, is known as the transpose. So the transpose is going to be denoted with a T. So the transpose of A is equal to A of T. Okay, so how do we define this? Well, if I were to define it pointwise, I would just say that the ith j position of this transposed matrix is just the j I position of the original matrix. In other words, we're going to reflect around the diagonal. So let me give a simple example. Suppose you had matrix B with entries 7, 1, 0, 4, -1, 3, 2, 9, and 6. The transpose of it is going to leave the diagonal fixed. So we're just going to rewrite the diagonal. And the off-diagonal numbers are going to swap. So 1 and 4 get switched. 2 and 0 get switched. And 3 and 9. And that should be a -1. Okay, so to see that this does in fact line up with that definition, let's recall that B1, 3, this would refer to the first row and the third column. And that particular element would be 0. However, what element would that correspond to in B transpose? So if I look at B transpose 1, 3, that's going to be 2. And if I look at B transpose 3, 1, well, that's going to go down to the third row and first column. That's just 0. So you can see that these two are equal, and I got that simply by switching the indices. Similarly, if I look at the original matrix, third row, first column, I would get 2. Okay, so effectively what it just comes down to, if you don't want to use this notation, you just identify the diagonal and then you swap. So that's pretty much it. Pretty straightforward, and it actually turns out to be quite useful for certain applications. Okay, so the next operation we need to learn is taking powers of matrices. So as you should know, if I had a number and I raise it to the second power, this is just the same thing as 3 times 3 in this case. So 3 squared is 3 times 3, and that's equal to 9. If I wanted to take a matrix A and square it, does that make sense? Well, that depends. What are the dimensions of A? Suppose A had dimensions 1 and, let's say 2 and 3. So the dimension is 2 by 3. How could I define A squared? Well, the most natural thing would be to just say that A squared is equal to A times A. However, this wouldn't work out because if you have a matrix A that is 2 by 3 times another matrix A, which has dimensions 2 by 3, notice that the inside indices do not match, and so we cannot produce a new matrix. We could do this if we took the transpose of A, but that's just not going to be the square anymore. So, in other words, the requirement for us to take the square of a matrix is just going to be that it's already a square-shaped matrix. So that's really easy to remember. So if you want to square a matrix, your matrix has to be square-shaped. And let's see why. So suppose your matrix A has dimensions, suppose the dimension of A is 4 by 4. Then A squared is going to be A times A, and both of the inner indices are 4, they match, and so the new size of the new matrix is going to be those dimensions, which happens to be 4 and 4, and so that tells us that the dimension of A squared is 4 by 4. Okay, so another neat thing is that the dimension of a matrix which is squared does not change. So let's do an actual computation. So suppose our matrix was 3, 1, 0, and -7. What is B squared? B squared is just 3, 1, 0, -7 times 3, 1, 0, -7. And to do this computation, we use the rules that we learned in the video titled Matrix Basics, which is itself based off of the vector multiplication in the video Vector Basics. So because this matrix has 4 elements, I'm going to split it up with that pair of lines there. And this first position, this is going to be position 1, 1. So I'm going to look at the first row in the first matrix and the first column in the second matrix. I'm going to multiply 3 and 3 to get 9, and I'm going to add that to 1 times 0, which is 0. So you should just get 9. For the second entry, I'm going to take 3 times 1, which is 3, and I'm going to subtract 7, because 1 times -7. Again, first row, second column in this position corresponds to the first row here and the second column here. Okay, so this position is row 2, column 1, so that should correspond in this matrix to the second row, and here the first column. 0 times 3 is 0, plus -7 times 0 is 0. So this is going to be 0 plus 0. And finally, second row and second column. So 0 times 1 is 0, plus 49, right? -7 times -7. So the final solution to this particular problem is the matrix 9, -4, 0, and 49. So in a similar fashion, you can define the powers of matrices that are higher than 2. So for example, if I wanted to do B cubed, this is just going to be B times B squared. And it's not difficult to see that that's the same thing as B squared times B. And this just follows because, as we've shown previously, matrix multiplication is associative. Okay, so that's the basics for matrix multiplication. The next and final topic in this video is functions of a matrix. So functions acting on a matrix. Okay, so there's some really deep mathematics hiding behind these particular topics, but we're going to keep it simple. So just think about ordinary functions. All right, so if I had f of x is equal to x squared plus 3x, right? That's a polynomial, and if I feed it a number, let's say -3, then the value of this is going to be -3 squared plus 3 times -3. And so -3 squared is going to be 9, and I'm going to add -9. And so in this case, that particular value is going to evaluate to 0. So it's not difficult to see that whenever you have a function and you put a number in, you evaluate it. You simply plug it in for every time you see x, you plug it in on the right-hand side, you do your calculation, and out comes a number. So we can also do this with matrices, provided that you're only adding and multiplying matrices, right? So I'll explain that in a second, but let's suppose you had that same function. So it was x squared plus 3x. And suppose our matrix we had was -1, 2, 3, and 7. What would f of a be? Well, we simply have to plug in, every time we see x, we plug in a. So this should give us a squared plus 3 times a. And now we just compute a squared and 3 times a. So what's a squared? Well, a squared, we just discussed how to do matrix squaring. So I'm just going to write the matrix twice and carry out the calculation. Okay, so -1 times -1 gives me 1 plus 6, right? 2 times 3. For this next entry, it's going to be -1 times 2, which is -2 plus 14. 3 times -1 is -3 plus 21, because 7 times 3, right? And then for the final entry, it's going to be 3 times 2, which is 6, plus 49 for 7 times 7. So simplifying, we get 7, 12, 18, and 55. That is what a squared is. Okay, well, what about 3 times a? Well, 3 times a, that just goes back to the matrix basics video, and that is a scalar multiplication. So this is just going to be 3 times every entry. So 3 times -1, 3 times 2, 3 times 3, and 3 times 7. After the dust settles, you should have -3, 6, 9, and 21. So we go over here and we summarize our results. What is a squared? Well, that is 7, 12, 18, and 55. And now I'm going to add on 3 times a. So that should give me -3, 6, 9, and 21. Finally, we add pointwise, also discussed in the video matrix basics. So we should have 7 plus -3, which is 4, 12 plus 6, which is 18, 18 plus 9, which is 27, and 55 and 21, which gives us 76. So in other words, if you evaluate this function by inputting a, you get out this matrix, 4, 18, 27, 76. Okay, and the last comment I want to make on this is that obviously if I had a function that ended with something like +2, right, then I could not perform this calculation. Why? Well, if I have a +2, then, okay, I plug in an a, then I get a squared, and I get 3 times a, then I have this +2, and then I have a +2 here, and then I end up with this matrix +2, and that does not make sense, right? That doesn't make any sense at all. It's not defined. It's not well defined. So what do I mean by that? I just mean that, remember, in order to add a matrix, in order to add matrices, well, both objects have to be matrices, and they have to be the same size. And 2 is not a matrix, so you can't add it. So that's all for this video. In the next video, we'll be discussing more on matrices.